I'll be talking about laser centering of powder beds, some academic research in that area. Um, so the first thing that I've got is just a quick video. And one of the things that SLM has is it has a very high laser power compared to some of the other machines on the market. And it has multiple lasers, where most machines only have a single or maybe a dual laser. They have up to 4 lasers on their highest performance machine. So you can see basically what it does is it fuses one image or one profile slice on the powder bed, and then it will step down the Z stage, and then it will level over a new one. You'll notice that it shoots the outside profile first, and then it does a solidification of the inside. And they can actually tailor the microstructure of the surface versus the infill differently based on process parameters like scan speed, laser power, things like that. So typically you want to engineer it to where you have the lowest surface roughness, so that there's a minimal amount of post-processing that you have to do. So again, there's really good reuse, and typically they'll do a preheated build chamber as well. And dimensional accuracy is very high, and fine part contours can be maintained. See the splines and the different features, the knurling on the outside of that feature and holes. That's as printed. Those are as printed. So, yeah. There's actually some really cool technologies out there which do selective catalytic, or not, reactive. Okay, so some of the things we talked about, powder properties and the types of powders can affect the process, scan speeds, laser power, and track overlap. There are some articles that I read based on how much you overlap and the way that you overlap, you can achieve different densities and different material property strengths and things like that. So the first one, this is the kind of the synopsis summary article: Consolidation Phenomena in Laser and Powder Bed Based Layer Manufacturing, by Kruth et al. And the cool thing that I really liked is that it consolidates these 220 articles in the field, and it talks not just about metals, it also talks about polymers, it talks about coated particles, it talks about ceramics, and it talks about all the different consolidation phenomena that you have to actually take into account when engineering the process parameters associated with it. And there's some that are not suited for certain materials and you don't see these consolidation phenomena, and there's other ones that are suited, and it varies based on the material as well. So these are some of the ones talked about: solid state centering, liquid phase centering or partial melting, full melting. So this second one is what they call SLM, where full melting is SLS. Typically, and then chemically induced binding as well. And then they've got various subcategories, whether it's consolidated powders, coated powders, things like that. And each different mechanism is suited for a different type of material and different process parameters. So this is one of the process parameters, or one of the processes, selective laser melting. It has the benefit of it doesn't have any binders or melt phases. But it's not suitable for things like ceramic composites, tungsten carbides, things like that. And you don't have to have any debinding, which is nice. There's no polymer to get rid of, so it leaves a very nice dense part as it finishes. So that's pretty much what I was able to do on the first research article. The second research article I'll talk a little bit more about next time, but I actually talked about some feedback loops, how it uses pyrometers and other things like that to actually control process parameters and control melt pool and things like that. And they had some additional models and things for different materials and heat transfer in powder beds. So we'll talk about that more later.